So I'm using a Duquesne PA amplifier for all these tests that I run, and my DDS signal generator is going on input number 1. I have my outputs connected to the low and the 70 volt high voltage output, the black and red lead. And as you can see, I got it jumpered for a 4 ohm configuration. So the red and black wire then goes around to the front so I can connect up to my coil. The test circuit that I used for all 3 coil comparisons and for the new coil, which I'm getting ready to demo, was this circuit right here. I have the DDS generator feeding into the input of my 60 watt amplifier, and that's set to 0.4 volts in. I crank the output volume of the amplifier to like in the first test where I set them all to 5 volts, I crank the output to 5 volts output. Use a sine wave for all the tests. I used a fluke meter and fluke scope to monitor the input. I used a fluke meter to monitor the input voltage across the coil. I used a scope to monitor the waveform and the current going into the coil. And I used the 2 Unity monitors across the capacitor and across the 2 ohm resistor that are connected in series with the coil to monitor the current by monitoring the voltage across the 2 ohm resistor, determine the current flowing through the capacitor, and by monitoring the voltage across the capacitor. And then I tune the frequency of the DDS generator to get maximum voltage out on the cap with the different load configurations and the different coils. This is the coil I'm testing. It's one that I made up to do additional, so I could get additional understanding of what's going on with these Rodin coils. This is not a Rodin coil, but it's kind of wound in the same way. I printed up a little spool on my 3D printer, and then I took some wire. I took took 2 strands of 24 AWG, which is the red wire, and I took 4 strands of 25 AWG, which is the green wire. I twisted them all together, and then I wound them. I made 2 sets of those, and I wound them together in a bifilar way. In other words, I wound both of the twisted strands together around the spool. I made 80 turns. So those 80 turns were wound around there. And you can see both groups there, group 1 and group 2. That's where they come out, or depending on how you look at where they go in. And over here down there at the bottom, you can see both groups where they come out. Then I took the strands and connected them together. The green ones in series, and the red ones I have 2 of the red ones clipped together there with just a little clip, and they've been stripped on the ends. And then the other 2 ends are right here where I can short them out. That's the shorting coil, and the signal's going in on the green wires. So in this case, those 2 coils will be the green wires. And I have the same 2 ohm resistor and 0.05 microfarad cap in line. Here's the cap. 0.05, which is 2 0.1 caps in series. And my good old standard 2 ohm resistor. So there's the coil again, and here's the output voltage. 64.9 volts out, 5 volts in, 0.375 volts across 2 ohms is the current through the cap. And we got 396 millivolts RMS across the input of the coil, across the 2 ohm resistor. So we have that value divided by 2 is the input current for the total circuit. This number divided by 2 is the current through the capacitor. This is the voltage through the capacitor, and this is the voltage across the coil. As you can see, there is not any Rodin coil configuration. I just wound the wires around there fast and dirty. Tried to keep them going bifilar, but didn't really have them twisted together too tight. So you can see it's just wound on there helter-skelter. So I replaced the fluke meter with this cheap meter, so it reads 5.3 volts instead of 5 volts. But anyway, I don't know, it's XL, some cheap thing I got for 10 bucks on eBay, because I need the fluke meter for my temperature. It has a temperature input. So I have this thermocouple adapter, and I have a little Type K thermocouple connected to it. So I'm going to connect that thermocouple to a piece of metal, which I'm going to insert into the center of the coil. So I have taped the thermocouple to a dental tool, which I've inserted down into the coil, and just set it down in there. Currently, the temperature is 31 degrees. I retuned the frequency to 7,790 Hertz because of the changes, the operating conditions when I put the dental tool down inside the coil. So the input voltage is currently 4.7 volts, and output voltage is only 18 volts, but good multiplication, and this is drawing not too much current, 0.077 millivolts divided by 2 ohms is the current. The input current is also correspondingly reduced. Now I'm going to crank the output voltage up to 30 volts. So there we go, 30 volts. And as you can see, the temperature immediately starts climbing on my dental tool. It's already up to 42 degrees centigrade, 43. So we're definitely getting the feature of inductive heating going on inside the coil there. With now our current has gone up to 340 millivolts over 2 ohms input to the coil. Temperature is now already to 62 degrees. Output current through the cap is 323 millivolts divided by 2 ohms. Output voltage is about 70 volts across the cap. So I don't know what the magnetic field is in there in the coil, but it's definitely heating up that piece of steel big time. So I was able to verify the inductive heating going on that I saw in one of the ABHA coil experiments from some years ago on YouTube. Although I didn't see it until after I discovered this accidentally myself when I burned my finger on my dental tool. So now it's up to 92 degrees, 93 degrees centigrade, so just about up to boiling water temperature. Okay, as you can see, temperature's climbing. I had it off for a minute, so that's why it cooled down some. But now this is the most interesting thing of all. I have my shorting wires here, right? It's connected in series, so all I'm going to do is short them out right here. So I short them out. Immediately it kills the magnetic field. There's no more heating going on. Temperature immediately starts dropping. Of course, the current dropped some to 175 millivolts. 100 divided by 2 ohms is the input current. Output voltage dropped from 60 some down to 35 volts.